Appreciate you guys coming to this session. You've got great speakers to talk about UAS and environmental planning as well as geospatial standards, right? So I'm going to turn it over to Wes to introduce himself, and we've got 1 hour for this session. Thanks.
Good afternoon, everybody. Thanks for joining us. Hope you're all having a great conference this year. I want to take a little time to talk to you about UAVs and how the NCDOT has been using them for some adaptive mitigation planning and how we're using them to monitor out at the coast. So again, my name is Wes Gardner. I'm an environmental program consultant with the NCDOT. I'm in the environmental analysis unit. Over the past couple years that I've been there, we've had great successful experiences deploying UAVs throughout various portions of the work that the environmental analysis unit does. We have used drones, or we have used a UAS-based approach for our Body Island Lighthouse mitigation site, which I will go into further depth on this in the presentation. But we have also used it aerial UAS-based LiDAR for wetland delineation, wetland predictive modeling, not delineation. We've also had successful experiences using some of the large fixed wing platforms like the Wingtra to do some bald eagle nest validation surveys. We're also using some of the thermal capabilities to assist with bat emergence and count surveys with our biologic surveys group. We've also done some red cockaded woodpecker habitat modeling with some of our drone work. And then our stewardship program definitely has taken advantage of taking the UAVs out. That way they can get accurate pictures of their mitigation sites and stewardship into perpetuity. And so we've had multiple successful experiences utilizing the UAS across the board for many environmental activities. But we're going to take a little bit of an in-look depth at the Body Island Lighthouse and how we're using drones for that. Just a quick area map so you can kind of get a rough location of what is and what is not there out at the coast. A lot of water from what you can see on that map, a lot of swampland as well. So just keep that in mind when we go through some of the site constraints of why we picked the methods that we did given the resources or the lack thereof in the area. So a little bit of background on Body Island. The Body Island site came to us through the Bonner Bridge replacement, or the Mike Bassanite Bridge, which is the largest bridge project for NC, but is also the third largest continuous segmental concrete box girder bridge in North America. It serves as one of the primary evacuation routes for NC-12 over the Oregon Inlet. It came to us per our project commitments for the mitigation needs for the B2500 project. These were camo wetlands. So as I will take a step back to this area, trying to develop in this general area, there was not a lot of land left that the federal government didn't already own for us to go out and get for our mitigation purposes. So we had very slim pickings. So given that site was there, that was how we came into acquisition of that. It was identified by the National Park Service and the North Carolina Natural Heritage Program as a significant area, and they deemed it the highest priority for our mitigation efforts. And so here's one of the original aerial photographs from, I believe this one's 2008. Thank you to our photogrammetry department who has joined us, and they've provided a lot of the base maps and aerial photography for this project. This is from 2008, and this was the original mapping effort of the Phragmites at the Body Island Lighthouse. The original NCDOT field mapping efforts concluded that there was approximately 50 acres of Phragmites. That was in 2008, and also it was about 30 acres in 2008 and has gone upwards of 50 acres since 2011. And at this time in 2023, we are still at about 60 acres of Phragmites that we are actively treating. And so how are we treating it? And we're treating it with an adaptive mitigation plan. So what is an adaptive mitigation plan or a management plan? And it's the process that allows for decision making in spite of uncertainty. And that was a big deal for using UAS in spite of uncertainty. So the general goal is to reduce uncertainty over time with monitoring the system. So we're going to use the drones and we're going to monitor it over time and hopefully reduce the footprint of the frag and or improve the way that we manage the frag over the process of the project. And so what falls under a successful criteria for this project? So there were three main criteria. And so the total area of the Phragmites needed to show a decreasing trend from the first year that we mapped it. So we first mapped it in 2008, and we have since continued that time. The second criteria was that it needed to show a general decreasing trend from each treatment year, which it has. I'll do it with some bumps, but that's part of the process. As well as the total area coverage that is left. We are looking for 10 acres or less, but those 10 acres also have to be at a 3-foot canopy height or less. And knowing Phragmites, that it typically can be found up to 10 feet to 15 feet in that general area. So getting it down to 3 feet definitely means we have a great control on it. So we are striving to meet those three success criteria. And just for a reference of what that might look like, on the left, you can see what we have deemed about a 10% coverage of Phragmites at a plot survey point versus our vegetation plot 3 on the right, which is about 70% coverage of Phragmites. So in that image on the right, you can see much more lack of vegetation, but also the black holes. You can see that the undergrowth has been removed from the Phragmites taken over. So we are trying to get the entire area closer to our coverage points on the left. And these were taken with a Skydio X2. So we will get into the actual UAS platforms that we've used to address each component of this project here in a minute. And so you may ask why? How did we end up at using unmanned aerial systems or drones for this project? Ground disturbance was a big portion of control or concern for the National Park Service. It is a swamp, it is wet. We cannot put any machinery, or they didn't even really want foot traffic out there destroying what was already there. So we needed to have ground disturbance and minimization efforts first and foremost to avoid compaction for the National Park Service. That being said, compaction and traversing the marsh. I don't know how many people have ever had to put on a backpack sprayer and maybe a Tyvek suit and start walking through the swamp, spraying above their head, but it's not exactly easy nor fun. So we tried to reduce the amount of people that we have actually in that environment. There are also multiple state-protected species out there that we have mapped. If we were to use traditional manned methods with either helicopters or airplanes, the precision of those platforms were not going to be enough for us to maintain the security of our threatened and endangered species out there. So we had to knock that down a little bit more and make sure that those species stayed protected. And then the overall site obstructions. There was an established tree line that basically encompassed the northern end of the project that at 70 foot tall, roughly 70 to 100 feet, traditional man methods had issues accessing the site. You had a high-power transmission line running down the highway, and you had 100-foot trees on one whole corner of the project. So approaching with an aircraft from altitude was not going to be very conducive to the situation. Also, back to the traversing the marsh, the research has shown that the more disturbance that you induce into a vegetation area with Phragmites, the more you will spread that Phragmites. So how do we treat something that we in theory can't touch? And so here's a little quick video that we can walk and talk through. If anybody has any questions, I'd love to keep this as informal as possible. Feel free to raise your hand at any time. But here's a video of our aerial herbicide applicator in action. We're being videotaped by another drone. All of our drones were on the blue UAS list per the federal government and the National Park Service. We had to go through rigorous amounts of paperwork and attestations that these drones were exactly what they said they were, and that they were American made, and that they would address our project needs as designed. I don't know if it may be too bright. Oh, there you go. Now you can actually see it spraying a little bit. So this little 2-minute video is about 4.5 months of glory summarized into 1 minute. So without further ado on that, we will go get back into how did we make that so streamlined? How did our unmanned aerial vehicle go out and just spray wherever we thought we were going to spray and get the Phragmites? And so we have our first map that helps us go through our process. And this is one of the original DOT maps that came from the origination of the project. And so we have our area, our Phragmites boundary that was originally delineated back in 2008. And then in the blue, you can see is the area that we traditionally treat since 2020 or since 2018. You can see all of the GPS points that we have for our staging areas and our vegetation plots that help us monitor how we are actually performing on this project. These are all of our metric points, the vegetation plots that I showed you earlier. So we fly out to each individual plot at the end of every season after we have sprayed it to kind of get the snapshot of that season's effectiveness. And that's how we're keeping track with the health of the Phragmites all around the property. And so first and foremost, we had to get a map that showed us where the Phragmites was. So we had to find, or we used multispectral modeling. So we used a fixed wing platform, the Wingtra, and we put a red edge sensor in there. And we were able to go out and essentially fly this entire area, which I think was upwards of 130 acres, the entirety of the site, in about 45 minutes. We were able to map not only with the Sony XR1 for RGB, we conducted 2 different flights, but also with the MicaSense Red Edge to get basically the inputs that we would need to calibrate our model that would then tell us this is where your frag is and this is where you need to spray. So this is that platform and what a snapshot of one of those flight plans would look like. And so here's just an overview of the RGB flight that we conducted. And I believe this was at about 350 feet altitude with a 42 megapixel camera, just so you can see the actual resolution that we were obtaining with those flights. Just a little snapshot of the observation deck out there. And if you can see with the glare of the sand out there, we do have control set through the majority of this site. I think we have about 6 control points that we aim to get in our flight plan every year, but sometimes vegetation has different plans for us. So we do have control on the site to try to tie it down. I believe last year we were within 0.1 to 0.15 RMSE between the X and the Y datums. Our vertical accuracy could have been better, but we were very, very close in the XY. We've got an additional arrow points that we're going to put out this year to hopefully constrain that a little bit better. But these were all residuals from the RGB flight. And here is a map of the actual multispectral flight that we got. And so you can really see the different colors of the actual returns being vegetation versus open water versus asphalt. And you can see on the left would be the map that our UNCW research project party was able to produce in 2018, I believe, or 2019, when we originally started this effort with treating it with the drone. So here's another close-up of the actual returns that we're getting in the RGB. And again, it's a little bit washed out on the screen, so I apologize. And so what do we do with that? We're basically able to take our multispectral imagery, which is measuring for reflectance values, and we're able to isolate the reflectance values of our Phragmites. And so given the specific time of the flowering cycle of Phragmites, it is registering on the spectrum of light at a given range. And so we can go in and essentially isolate that range of reflectance values, and that's how you get these polygons that you can see in red. So it basically will isolate every pixel return of frag that is in that flowering window. So albeit last year we tried to get our data and it was a little bit too far into the flowering cycle, so it had a different reflectance signature. Therefore, our returns were not as strong as we had hoped for them to be. So this year, weather permitting, we're hoping to obtain this data earlier in the flowering cycle, therefore more accurately representing the Phragmite that's still out there. So here's a closer image of how we actually delineated those polygons. So we're not after every single stand every individual read of the Phragmites, but we are trying to address as many of the clusters as possible. So you can see where we have delineated those polygons in the actual model and created clusters from them. So when we have all of our clusters actually dialed in, what do we do with them? So we went and had the original AOI. On the left, you can see that was from the original delineation. And on the right, we were essentially able to dissect that whole area of operation into almost 10 different individual flight plans that we were able to upload into the aerial herbicide applicator. And so we were able to take the GPS and the accuracy of our shape files from our imagery that we delineated and take them into individual flight plans per area that we can address with accuracy and precision with our pesticide to make sure that we're not putting it into the water or putting it on the mature tree line that the National Park Service would not be happy with us if we killed their trees. They would not be happy at all. And planning ahead, we're hoping to use even more drones. The U.S. Forest Service is looking to bring their Dragon Egg platform with us. We're trying to get the National Park Service on board and finalize their burning safety plan so we can do a controlled burn at the site. It hasn't been burned since 2012, and while we are actively spraying every year, we are creating a much larger biofuel load than we would care for, but also we're not allowing the natural vegetation to actually thrive as well as it should once we do kill the frag. So that's kind of our hang up for right now. We're really trying to get in there and burn all of the biofuel and the dead frag that we have been killing for the past 3 years in efforts to make the natural vegetation have efforts to grow again. So just in summary, between the RTK and the GPS shape files for plot monitoring and flight planning, we're able to accurately dial in exactly where we need to send our drone to spray the herbicide to treat the frag. Between the consistent mapping and the ability to detect the changes of the frag as it migrates, either as we reduce it in some areas or it pops up in other areas, we're able to keep accurate maps of it, which aids our adaptive management plan through the project perpetuity. We were able to roughly spray 7 acres an hour. So the 60-acre project we were able to achieve in about 2.5 days last year, and that was with excellent weather. We've had previous experiences where if the weather's not on your side, you could be out there for weeks. You may be out there for a whole month. But at first in flight and out at the coast of North Carolina, where wind is king, it's very hard to spray herbicides and winds less than 10 miles an hour. But those are some of the constraints that we have to deal with. And first and foremost, or lastly, it's much more safe than having to put somebody, an actual man on the ground with a backpack sprayer and trying to spray 60 acres of Phragmites. So we're hoping to maintain the safety factor and the accuracy and keep on completing the project. And it's always fun when you're breaking government rules for the government. So at the National Park Service, you're not allowed to fly drones in their territory. So you got to get a picture with your drone that you're flying in their territory before you go. Thank you. Are there any questions? All right. Yes, Ms. Marissa.
I might have missed this, but how long do you guys have to do monitoring for? What's the time frame?
The 3 success criteria are showing substantial decreases in overall coverage. So when we originally mapped it, it was about 50 acres. So we need to show a decreasing trend from there. But then also we need to get the 50 acres down to 10 acres. And those 10 acres must have a canopy height of 3 feet or less. So we will be...
There's not like a 10-year,
correct.
15-year.
Not to my knowledge at this point. I believe that is the portion of the adaptive plan that we were still working on. Yes, ma'am.
So what issues have you run into besides weather with running the drones?
Per the drone, not much. We have moved from a DJI Agris platform that we've used in the past to a Helios AG110, and it has been amazing. You can fly it by hand with a controller, or you can use the autopilot functions on the computer. Flying it by autopilot basically takes the controller away from the pilot, and it flies itself by the GIS. So it will go right back to your shape file of the flight plan that you made. Obstacle avoidance is always an issue. How far can we push our limits? I would like to not fly my drone into a tree line and lose it, but I don't want to leave 30 feet of Phragmites out there if I don't have to. So we're expounding upon that.
Was most of the flying automated, except like on tree line?
Yes, sir. We're able to spray 0.91 acres per flight with our aerial herbicide applicator. That's per battery per tank. That's a 10-liter tank, 3 gallons. We can fly out quarter mile, almost to a half mile, 2,400 feet, spray our acre, and fly back all in about 11 minutes, 12 minutes. So we're averaging 6 to 7 acres an hour. It's very smooth. Yes, sir.
Wes, one thing I want to mention in response to that is the reduction of staging areas. That was a big.
Very, very much so.
For this past year.
Let me pull it up so we know what we're talking about. There we go. So on this map, you can see that we have the green circles are the staging areas. When we originally conducted this project, we were using a DJI Agris that just didn't have the same range that this project or that this drone did. So where you can see 2 of our staging points along NC-12 and then 1 staging point down here at the southern point by the lighthouse, we were able to reduce, I believe we had almost upwards of 6 or 7 staging points in prior iterations of this. With the increase in range of our drone and the ability, the efficiency that it has, we were able to hit more places without having to break down our operation and lose time transporting and moving through the swamp to set up our scaffolding from point A to point B. We can reach roughly 20 to 25 acres from each individual staging point. And that was amazing in amongst itself. Thank you, Ben. Yes, sir.
How much was the cost for this whole process?
For the whole process or just for the specific platform that we used?
Yeah.
For the aerial herbicide applicator, that platform itself, I think, is about $25,000 right now. With the other ancillary things that you'll need to keep it running, batteries and props and chargers and whatnot, I believe we're all in on that platform for about 30. Yes, sir.
Curious about your battery management. How do you keep the batteries charged?
So we have 10 batteries. Each battery is about $700 a pop. We have 2 chargers. Each charger can charge 2 batteries at a time. So in theory, we can keep 4 batteries charging at all times. It takes about 30 minutes to charge each battery. We had a Honda 2000, I believe, a small Honda generator. Can run both of our chargers and charge 4 batteries. And so when I can go back and tell you that a battery per flight will get you an acre, so 0.91 acre per battery. And if we're flying 6 acres, 6 flights per hour, we're using 6 and we have 4 on the charger. So we have enough batteries to basically, we don't have any downtime. And that is one of the caveats that you can rinse and repeat and use this same methodology, but that you have to have enough batteries to make sure you're not having downtime to make it worth it.
Along those lines, in addition to the batteries, we also had a large portable water tank with us, which helped us keep.
This is Mr. Ben Furr with the Davie Resource Group. That is one of our consultants on the project, so he is also a very large knowledge wealth. Yes, sir.
You mentioned the obstacle avoidance.
Yes, sir.
So, did you keep the obstacle avoidance, the sensors on or off?
We kept them on, but we did have to do a lot of testing in different areas to figure out how that obstacle avoidance is actually going to work. You know, some models, they'll detect an obstacle and then it'll stop and it'll wait for your input. Others will try to move around it. We didn't know what was going to happen with our platform, so we did have to test it a lot. And when you're flying only 10 feet higher than the ground of what you're trying to actually spray, there wasn't a whole lot of room for error. So yes, at Body Island, we have mostly homogeneous wetlands out there, but there are large shrubs that are above average every now and then, that would cause that obstacle avoidance to stop and think. So it has 3 obstacle avoidance sensors, front, back, and below. And so we really were trying to figure out the bottom one. I'm not worried about left or right as much as I don't want to come within 3 feet of that wax myrtle that's standing 7 feet taller than everything else. So we turned it off just to make sure that it was operating the way we needed it to operate, but then we did turn it back on and have to go further into our analysis to make sure that it wasn't going to behave or misbehave. I believe I got time for one more. Yes, ma'am.
What is your flying height when you're doing your treatment? And do you keep visual line of sight if you only have an geospatial?
Yes, so we fly at about 12 to 15 feet above canopy height with the herbal applicator, and we are maintaining visual line of sight. We have scaffolding that we set up in that little in the right of way or right underneath the power line, and it's just 2 sets, so it gives us about 10 feet, and we were able to see our big white bird throughout the entirety of the process. And that was also one of the big things, that we have to maintain visual line of sight, and so the fact that we don't have to break down scaffolding 9 times is perfect. I believe that's all the time I have for questions, so I'll turn it over to Mr. Nick. Thank you so much.
Uh-oh, it's not working. Let me try to reopen it. All right, there we go. Good afternoon, everyone. My name is Nick Short. I'm with the photogrammetry unit. I realize I'm standing between, I think, you and your Wednesday afternoon. I'm also heading on vacation this afternoon or tomorrow morning, so I will get through this as quickly as possible. Hopefully this will be also informative too. Before I start, I do realize this will primarily be catered to the geospatial data provider. However, I do feel, and so do the standards do, that this is also important for the geospatial data user to have somewhat of familiarity with this. So today I'm going to quickly run through and kind of go over what geospatial data is. For those that are not familiar, I'm going to touch on what standards are, go through some common geospatial accuracy standards, and then kind of hone in on one of the most well-known and common and used geospatial standard in the industry, which is the ASPRS 2014 standards. So who here has used like Google Maps or NC1 map, or maybe used like a GPS to navigate to the McKinnon Center today or yesterday? So pretty much all of us obviously have used geospatial data. This is in our everyday lives. And essentially this is information that is tied to a geographic location or position on Earth's surface. All right, so this could be rivers, roads, buildings, fences, bridges, even you as a person on your GPS navigation system. This data is obviously collected through various sources. It could be done through satellites. It could be done through aerial imagery, whether it's on a balloon or on your phone or on a UAS or drone or a manned aircraft. It could be done through ground surveys, through active sensors or active technology such as LiDAR, synthetic aperture radar, so on and so forth. So again, what are standards? What are we talking about today? These are documents that provide guidelines, requirements, and specifications, or other criteria that ensure consistency, interoperability, quality, safety, and efficiency in products. They ensure excellence, right? The car you drove today, had to meet multiple strict, safety standards in order to be sold in North America, emission standards. I'm sure everyone in here today uses some sort of, whether national, federal, or maybe your specific business unit has standards in their everyday job. So again, I want to focus too and kind of tie all this together. So we're talking about geospatial standards and in particular, just accuracy. So these standards that I'm going to talk about, it doesn't tell you, how to collect something, what vehicle to use, what method to use, how you should display it in your CAD environment, so on and so forth. These national and federal standards are just on how to measure accuracy and report accuracy. So obviously, why they're important, quality assurance. Having a repeatable, solid framework for evaluating the accuracy of your data is critical, and making sure that it is fit for its purpose. Interoperability. This is a really big one. The AEC industry has been talking about, 3D models, digital twins, as-builts, BIM, so on and so forth. And then we start talking and having conversations about clash detection. I know a lot of people are really interested in clash detection, and that's very, very close in our future. But making sure that all this data is integrated seamlessly between different agencies and different business units and firms and so on and so forth will really ensure that we can provide that clash detection and this 3D digital world that we're going to be entering into. Obviously, there's legal and regulatory compliance. So if you're obtaining geospatial data from like an airborne or spaceborne type survey, doing like topographic mapping here in North Carolina, there's state in the law and the North Carolina Administrative Code very strictly on how to report accuracy and how to measure accuracy. And we'll talk a little bit about that too. Obviously, risk management, cost-effective solutions. You want to make sure that your geospatial data is accurate, because if it's not, you could have financial losses. All right, so common geospatial accuracy standards. I'm going to actually start from the bottom up. So the first one on the bottom is the National Map Accuracy Standards of 1947, and then the US Dot Reference Guide Outline 1968. These two obviously are irrelevant today due to the digital world that we are in now. These two standards basically say that you measure horizontal accuracy as a function of your map scale, and then your vertical accuracy as a function of your contour interval. Obviously, in your CAD environment, you can change those two things by a click of a button or a few mouse clicks. So those are irrelevant. Same for the ASPRS 1990 standards. Those again are irrelevant. They're based more on published printed maps to where you can't change scale and contour level with a few button clicks. So along came the Federal Geographic Data Committee standard, also known as the National Standard for Spatial Data Accuracy. This was published in 1998. They collaborated with ASPRS as well as a host of other federal national agencies here in North America. And this finally basically set a standard that could be used for digital geospatial data. And Wes was talking about RMSE, and so that's what they state is you measure accuracy both horizontally and vertically with your root mean square error, and you also report it at a 95% confidence level. And I'll talk a little bit about that in a sec. And then lastly, ASPRS Positional Accuracy Standards of 2014. Again, ASPRS helped Federal Geographic Data Committee on their standards in 1998, so they're essentially kind of repeating and endorsing that standard, as well as updating their 1990 standard, and kind of also expanding on some other things too. So what is ASPRS? I assume most of us don't know what that is. So it stands for the American Society of Photogrammetry Remote Sensing. They're made up of over 100 of the biggest and largest, most well-known geospatial and engineering firms, thousands of members, and they're just dedicated to the advancement of the science of photogrammetry and remote sensing, as well as to just promote the ethical and professional use of these sciences. And then obviously they're responsible for industry standards and guidelines. You can see here from the pictures that I have, they also author many books on remote sensing, photogrammetry, so on and so forth. Host a number of conferences at like regional and national levels throughout the year too. So very, very well-known society in the geospatial industry. So let's start talking about their standard. So again, this is the standard just addresses accuracy. That's all they address is accuracy, how to measure, and how to report accuracy of digital geospatial products. Standards intended to be used by obviously geospatial data providers, but also users too as well. I think if one of our customers came to us and said, hey, I want an accuracy class, a horizontal accuracy class of 5 centimeters, can you do that for me? It would blow our socks off. But if not, that's fine. We can walk you through everything. So types of geospatial data covered in the standards, very common words that most of us probably are familiar with or even use on a daily basis is digital orthoimagery, digital planimetric data, and digital elevation data. And this could be derived from many different sources. They primarily, this standard, this ASPRS standard is mainly catered towards like the airborne LiDAR and airborne photogrammetry type standards and sources. So anything from satellite data to UAS or drone data or an actual crewed aircraft type data. All right, so get a little bit more into the positional accuracy standards. I'm not going to sit here and obviously read, but some of these little boxes down here are straight from the standard and tried to highlight some important things. But basically, you are to use a statistical analysis using root mean square error. For those that don't know what root mean square error is, it's essentially like a standard deviation, except you're not subtracting your mean from your residual. It's essentially a statistical value to be used for accuracy, where your standard deviation is used for precision, right? There's two things in surveying. We're interested in accuracy, but we're also interested in precision too. Also, we can calculate for more precise error analysis our mean error to get our systematic biases. Skew, kurtosis values also can be used. We don't do that, but it is in the standard, and they talk about it a little bit. Again, too, this is just for measuring accuracy. We want to report accuracy at a 95% confidence level. And I'll talk about that in the next slide. Before I do that, checkpoints, right? Talked about residuals. We need checkpoints, right? In order to measure accuracy, not only do you need checkpoints, but they need to be an independent source from your map. You can't use a checkpoint that's inside your map and then, assess accuracy. It's like having like a chili cook-off, and all the folks entering the contest are also the judges too. It's going to skew the data, right? Everyone's going to vote for themselves. So checkpoints are very important. They also need to be of higher accuracy, and we'll talk about that too here in a little bit. All right, so I keep talking about 95% confidence level. So you can kind of see here this little table, and again, the standard states too that you need to measure, your vertical accuracy and your horizontal accuracy separately, and then you also report them separately. So here on the first table is your horizontal accuracy class. I don't think you'll be able to see my mouse, but you can see where it'll say, less than or equal to 2.448 times X, right? So say a customer or client comes to us and says, hey, I want a map horizontally accurate to roughly 2.5 centimeters. Then I can go to this table and use the crosswalk and come to my root mean square error and say, okay, I need to be within 1 centimeter. And same thing for the vertical accuracy. Here, the vertical accuracy, it depends on if there's vegetation or not. So if you're in an area where you'll see NVA at 95% confidence level and VVA, the NVA is your non-vegetated vertical accuracy, and the VVA is your vegetated vertical accuracy. You can see that factor of safety on that vegetated vertical accuracy is much higher than the non-vegetated. Ground control and checkpoints. Basically, the standards state that these need to be at least 3 times as accurate as your map intended purpose is to be. They're actually going to change that, or at least they're talking about it, and we'll talk about that in a little bit. All right, so limitations. We're almost done. I think I'm blowing through this too. Methodologies of accuracy assessment of linear features. There is none. There's no robust statistics for data sets that do not meet criteria for normally distributed data. They keep talking in the standards, hey, your data needs to be normally distributed to use all these statistics and use root mean square error to measure your accuracy, and have lots of faith in that number. So if your data is not normally distributed, then it's not going to work. Image quality factors obviously are a big one they don't talk about. No robust assessment of checkpoints, right? We talked about it, checkpoints. You can't place all your checkpoints in one spot of your geospatial data product, like your map. They need to be well distributed. However, they don't go through what that looks like, right? So they just kind of say, use your professional judgment. No best practices or methodologies needed to meet any of these accuracy thresholds. So they just kind of state this is what it is, and they don't tell you how to get there. And some of these are changing, and I'll talk about that in a second. So where to find these standards? So ASPRS.org, you can go to the top page, or on the home page, you can see there at the top with the red arrow, the positional accuracy standards. I think it's like a 20 or 25 page document. It's very easy to read. There's tons of examples with numbers. Again, the math is not difficult. This is not rocket science. And it's very easy to read. I highly recommend, all geospatial data providers, print this and read this thoroughly and keep a copy close by. Of course, users are also recommended to just go check this out and look through it. Even the foreword and the purpose of it is just a good read. Again, important, I just want to recap on why these are important. Obviously, quality assurance, and interoperability, especially with where we're going in this digital world, and we keep talking about as-builts and digital twin and BIM, and we're opening up a whole new realm that we're going to be getting into, making sure that we are consistent and all on the same page, with measuring and reporting our accuracy will really be crucial. Obviously, legal and regulatory compliance, risk management, cost-effective solutions, so on and so forth. All right, the future. So they're actually talking about eliminating the reference of the 95% confidence level as an accuracy measure. There's been lots of confusion between root mean square error and 95% confidence level, so they have been talking about eliminating that. I think technology is getting better to where your root mean square error is a good quality and a good number to use for your accuracy. Again, note the fine print at the bottom left. This is all subject to change. So these new standards are supposed to come out this year, but as of, I believe, today, they have not. They're going to relax the accuracy requirement for ground control and checkpoints. So if you remember it, I said it needs to be 3 times as accurate. They're going to dial that back to twice as accurate. They're also going to start considering your survey checkpoint accuracy when computing final product accuracy. So that's new. That will be interesting. Another one, they're talking about increasing the number of checkpoints from 20 to 30. I think we already get enough complaints of having too much ground control, and now they want us to have more. So we'll cross that bridge when we get there. I think most of our projects are pretty big, at least in the photogrammetry unit. That shouldn't matter too much. But again, we need to be able to guarantee the accuracy of our data, especially if we were to go to court or something like that and need to back things up. Another thing, the introduction to a 3-dimensional positional accuracy. Again, I keep harping on digital twins and 3D models and as-builts and so on and so forth, and we're getting into this 3D world. The standards currently have, both your horizontal and vertical components are separated, right? But now we're getting into this 3D world. We need to be talking about this 3-dimensional positional accuracy. So they're going to have a third component where you measure and report accuracy for your 3-dimensional positional accuracy. And then lastly is best practices and guidelines. So I told you before, currently they don't tell you how to get this accuracy and how to meet these thresholds. They're going to change that. So they're coming out with general guidelines, best practices for field surveying and ground control for checkpoints, coming out with mapping with photogrammetry, mapping with LiDAR, and mapping with UAS. So I think this will also be a really, really welcome change, and I think that will also be a benefit to a lot of us, especially us geospatial data providers. So that's all I have. I'm a few minutes early. If anyone has any questions, if not, feel free to shoot me an email or give me a phone call. I'll be here for a little bit longer today.
Just a standard 50-scale base map, what kind of accuracy are you looking at?
So you're talking, it depends. What are you collecting? For base map from photogrammetry, we're within a few tenths. Of course, as you get lower to the ground, then your spatial resolution, will increase slightly. And of course, being boots on the ground, you're talking, hundredths within a foot accurate. So depends. Oh, go ahead, Mark.
On the previous slide there, future, talk about increasing the number of checkpoints. Is there any basis on that, on the area you're dealing with? I mean, 20 to 30, I mean, is that on an acre? Is that on 100 acres? What are we looking at in that particular one?
Unfortunately not. To do a true statistical assessment, you need a good sample. So to answer your question, no, you need, this is what they state, that this is how you guarantee accuracy. Now, that doesn't go to show is you can report your accuracy. There's two different ways to report your accuracy. You can say, hey, I tested to meet this, or I produced to meet this, right? So once you get familiar with your equipment and your process and software, you could probably get away with, not having so much. But again, the only way to guarantee that accuracy is to have those, 20 currently checkpoints and 30.
You mentioned clash detection.
Yes.
Can you elaborate on that?
As best as I know, so say you're working on a business unit, maybe utilities, right, and you're designing your utilities, and you could, essentially another designer, maybe this is a bridge designer, roadway engineer, something like that. They can tell if their design is clashing. Yep. Any other questions? Good questions. All right. I'll let Wendy wrap this up then. Thank you. Yeah, go ahead, Mark.
In the standards that are out there now, is there any guidelines on how much control back to an area you're taking? Is there something in there?
That all depends. It depends on what accuracy you're trying to use. It depends on what sensor you're using. Are you using photogrammetry? Are you using LiDAR? So to answer your question, no. However, with the new standards coming out, I have not seen those. They have not kind of put out a little taste of the best practices, but maybe something in there will be in there. So yeah, it all depends. Yep. All right. Thank you, everyone.
Well, thank you all for attending. Really appreciate it. That's a wrap, and I hope you got a lot out of not only this, but the workshop itself. I hope you found value in that. If you need anything, Nick and Wes, they'll be here at the front. We've got a few more minutes, or free to go. So thank you.